This is a quick tutorial on acid-base chemistry to get us started in the spring semester aquatic chemistry course. So aquatic chemistry is going to use water as a solvent, and it's important to recognize that water can act as both an acid and a base, and that the dissociation of water is going to form H plus and OH minus. Now this equilibrium has a very small dissociation constant, and we call that the Kw, where the W indicates it's the dissociation constant of water. It's equal to 10 to the minus 14, and it's products over reactants for a chemical equilibria. So I've got H plus times OH minus, those are my products, and we have ignored the water because it is a pure phase, which has an activity or a concentration, and in a few weeks we'll differentiate between concentration and activity. But for right now, its concentration is 1, and since it's 1, we typically ignore it in the equilibrium expression. Okay, so we set the concentration of water to 1 since it's a pure phase, and so we have 10 to the minus 14 equals H plus times OH minus. Now this is helpful because if we know the OH minus and we know the Kw, then we obviously know H plus. And similarly, if we know the Kw and H plus, we know the OH minus. So we can convert between hydrogen ion concentrations and hydroxide ion concentrations by simply knowing the Kw. We can also work on a log scale, which is very common in environmental systems, where the pH is the negative log of the H plus concentration. So it's important to remember that P is a function, and that function means negative log. So P of the H plus concentration is pH, negative log of H plus. P of the Kw expression is pKw. And so if we take the log of this expression, I get log Kw equals log 10 to the minus 4 equals log H plus log OH minus. And of course, that can be reorganized to pKw equals 14, which is equal to pH plus POH. And we should say at 25 degrees C, because the pKw of water does have a temperature dependence. As we move from in pure lakes, 14 is a pretty good estimate for the pKw. As we move into seawater, where we have significant concentrations of ions, we will have to correct for the salt effect on the pKw. And again, later in the semester, we will talk about activity coefficient corrections, which is the approach we will take to correct for the salt effects on the acid-base chemistry of water. But right now, pKw equals 14 at 25 degrees in pure water, and it's equal to the pH plus the POH.